Friends, once again welcome you all in my YouTube channel Pacific Chemistry Classes by Mahima Laharia. Students, today I am going to discuss the postulates of the Debye-Huckel theory. It's very important for our every chemistry class students, like it's in electrochemistry from PU level and it's in BSc, MSc, and many questions has been asked from the KSET and NET examination. So let us start. As we all know, what are the strong electrolytes? So strong electrolytes are completely ionized at all dilutions. For example, if we talk about a strong electrolyte like our NaCl, so Na plus and Cn minus can be easily ionized in minimum dilution also. But if we talk about our weak electrolytes, so they are not ionized at all dilutions. So before Debye-Huckel theory postulates, just you should know many theories has been given to explain the behavior of our weak electrolyte, strong electrolyte, like you have heard about the Ostwald dilution law and Arrhenius theory. So these theories have some drawbacks, and so to remove those drawbacks, this theory is proposed by the Peter Debye and Eric Huckel to explain the behavior of a strong electrolyte in 1923. This theory was developed by Onsager. Means first of all, this theory was given by Peter Debye and Eric Huckel, but the modifications and developments are done by Onsager. So after the postulates, there you have to do the derivation also, Debye-Huckel-Onsager equation. So Debye-Huckel theory satisfactorily explained the strong electrolytes both qualitatively and quantitatively. Why this theory is successful? Because it considers both the aspects of these strong electrolytes, like qualitatively as well as the quantitatively. So just we will talk about the what are the main postulates of our Debye-Huckel theory. So first of all the strong electrolytes are completely ionized in all dilution. What is the first assumption? That all the strong electrolytes are completely ionized in all the dilution. That is, the degree of ionization is 100%. Means if it is a strong electrolyte, it will be completely ionized in all the dilution, whether the dilution is less or high, their ions will be easily separated. Okay, so second point, the relation lambda V upon lambda infinity for the strong electrolyte does not represent the degree of ionization, but it is the only a conductivity ratio. Means the relation lambda V upon lambda infinity means it is a dilution at a volume V, or it is the conductance at the infinite dilution. It does not explain the degree of ionization, but it's only the conductivity ratio. So the third point, the increase in the ion conductivity, that is lambda V of a strong electrolyte solution on dilution, is due to the increase in the mobility of ions. So what they are saying, that if suppose there is increase in the conductivity of any solution, so it is not because of dilution increase kar rahe or decrease, but it is due to the movement of the ions. Okay, so these are the first 3 points. Next point, the two ions present in the solutions obey the Coulomb's law. Okay, so as we know that if it is any solution, suppose if it NaCl, na, so this is Na plus, this is Cl minus. So these are the two charges, na. So what does the Coulomb's law says, that Coulomb's the two ions present in the solution will obey the Coulomb's law, that is force will directly proportional to the Q1 and Q2 by R square. So we have already studied in our 9th standard also, the force is directly proportional to the product of the two charges like Q1 and Q2, and it is inversely proportional to the square of the distance between them. So it is simple. So then next point, each ion is surrounded by the ionic atmosphere of oppositely charged ions. The positive ion is surrounded by the negative ions, and the negative ions are surrounded by the positive ions. The details of the formation of the ionic atmosphere we will see. So this point is very simple, that each ion is surrounded by the ionic atmosphere of the oppositely charged ions, and the positive ion is surrounded by the negative, and negative ions are surrounded by the positive. So for example, so this we can say that if it is our positive charge, when there is no electric field applied here, so just you can see that positive charge in the center and the negative charge are symmetrically around. Okay, but if this is the symmetrical ionic atmosphere, but if we apply the electric field, so what will happen, this positive charge will move towards the negative terminal, okay, negative side of the field. Okay, so what will happen if the positive is moving toward here, so all other negatives are getting disturbed. तो क्या हो रहा है आपका, the ionic atmosphere which was symmetrical before, it is now getting asymmetrical. So just these are the main postulates. If in your exams they are asking you write the main postulates of the Debye-Huckel equation, sorry, on Debye-Huckel theory, so just you can just write the all the postulates. Okay, hope now these are easy points. So just in the first point you have to tell that all electrolytes are completely ionized in all the deletion. Second point is the lambda b by lambda infinity is not only does not represent the degree of ionization, but it's only the conductivity ratio. Third is the if the dilution on increasing the conductivity, it is because of the mobility of ions. Fourth point, you have to write about the our F is proportional to the Q1 Q2, means our the two ions present in the solution will obey the Coulomb's law. And the fifth point is regarding the ionic atmosphere. So what is ionic atmosphere? That each is surrounded by the opposite charge ions, means if it is our NaCl, so sodium will be surrounded by our 6 Cl minus ions, and Cl minus will be surrounded by our 6 sodium ions. So this is our ionic atmosphere. Okay, 6, if it is 6, it is surrounded by the 6 positive sodium charges. Okay, so I hope this is easy for you. So do subscribe the channel and do comments. Thank you.